Okay, we're graphing some more square root functions. So with that said, remember square root functions look like eyebrows. So they start with the vertex and then they look like a quadratic that fell over and got chopped in half. So here it is. We're going to start with we're just going to do an ugly one. So here's an ugly one. It's got a bunch of numbers everywhere. So let's talk about how do I find the vertex of this. So let's think about it. It's the same thing we did last time. We're going to be looking for a vertex, and that vertex is going to occur when the stuff inside the root sign equals 0. So when x minus 3 equals 0, we can start talking and graphing points. If this number is less than 0, then we have an imaginary number in here, and it doesn't make any sense. So when x equals 3, that's going to be the first point that's going to matter. So x equals 3 is going to be the x value of our vertex. And calculating the y value is going to get a little complicated. We got a minus 2 out in front times the square root of 3 minus 3 plus 4. So notice how this has a little tail at the end. That means the root sign ends after the 3 and then you add 4. So be careful when you draw them out. Make sure it has a little tail at the end to stop. So 3 minus 3 is 0, which means this whole thing turns into 0 plus 4. So I found my vertex. It's going to be at 3, 4. So I can count over 1, 2, 3 and up 1, 2, 3, 4. There's my vertex. Now I need the next value. So remember my perfect squares I had? 1, 4, 9, 16, 25. Well, how can I produce something in here that would have a perfect value of 1? Well, if I want a perfect value of 1, x would have to be 4. So if x was 4, I'd get minus 2 times the square root of 4 minus 3, and all of that plus 4. So that's going to be minus 2, and remember, the square root of 1 plus 4. Well, the square root of 1 is 1. So negative 2 times 1 plus 4 would be negative 2 plus 4 is a grand total of 2. So I could go over 4 and up 1, 2, which is going to put me right here. It's not what I expected. Now I'm going to look for the next one. The next one is going to be a 4. So how could I produce a number in here that would be 4? How can I make x minus 3 equal to 4? Well, if I want x minus, I could write an equation. If I have to, I could just say, hey, when does x minus 3 equals 4? Well, that's when x equals 7. So, yeah, that makes sense. When x is 7, I'm going to get 7 minus 3. So I'm going to get minus 2 times the square root of 7 minus 3 plus 4. So that's minus 2 times the square root of 7 minus 3 is 4. So negative 2 times the square root of 4. So the square root of 4 is 2. So negative 2 times 2 is negative 4 plus 4. Grand total 0. So 1, 2, 3, 4, 5, 6, 7, 0. So what happened to our eyebrow here? Well, it looks like if it starts here, that it's going to go upside down. So it's going to drop down this way and start heading off the paper that way. So it's an upside down eyebrow. So what about this equation leads you to believe it's going to be upside down? Well, just like a parabola, if our value in front of the root sign is negative, we get something that's upside down. So let's talk about what this really looks like. So let's remember HK form for parabolas. Remember HK form for parabolas? Well, we can have the same idea of HK form for a square root sign. So when we think about it, where was our vertex? Well, our vertex was right here. So our vertex for this was at 3, 4, HK. And our A value, well, our A value was, when I went over 1, this dropped down 2. So our A value was minus 2. And sure enough, all of the other stuff is just the same. So I would get y equals minus 2 times the square root of x minus 3 plus 4. That's exactly what we have up here. So this AHK equation still works. If I can produce something in this form, I can graph it the same way with an h and a k.